So question 1, part D. Use your graph to describe the relationship. So to describe the relationship between the wires and the current. So we've actually got 2 marks here. So we're going to have to find 2 things to say. Well, the first basic relationship is that as we increase the number of wires, the current also increases, and that's a mark that nearly everybody got. So as you increase the number of steel wool wires in the circuit, the current required to break the circuit, or the highest current circuit, also increases. So that simple relationship. Then we need a second mark, which is higher. So it's aimed at the higher grade candidates. So we're sort of saying here, is this a directly proportional relationship, or does it increase slowly at first and the rate of increase is higher later? So we need some other point here. This is, in my opinion, a direct relationship. I could put a straight line on this. It's a kind of linear relationship. So this is directly proportional. Yeah, it's a straight line on my graph, and that's the second mark. Explain the number of strands of steel wool wire that should be used for a circuit using 1 amp of current. So if I want 1 amp of current, how many wires do I need? And this is really talking about fuses in circuit. So if I had a circuit with a really expensive piece of equipment there, and let's put in a variable resistor, and let's put in my fuse there. So my steel wires there, for example. Then I can increase the current and operate my expensive piece of equipment here, but if this gets above a certain current, then this is going to damage this equipment. And so this steel wire is acting like a fuse, where this will burn out when the current gets high enough to start damaging this piece of equipment. So it'll burn out before the current gets to a kind of dangerous level, and that's what fuses are. So Google fuses, get fuses on YouTube, and find out about why would we have a fuse. In this situation here, then I'm going to, it says 1 amp of current. So 1 amp of current is there. So I'm going to draw across from 1. Okay. And I'm going to use my line of best fit rather than my actual points. And then, so for 1 amp, this crosses at 2.9 wires there. Don't write on your graph, I'm just writing on this to show you how I'm working it out. So if I had 2 wires in this circuit and I put 1 amp through it, they'd burn away. If I put 3 wires in, I could have 1 amp. If I increased the current a little bit more, then those would burn out. But for 1 amp of current, 3 wires is perfect, and then it's acting as a fuse perfectly, because if I bumped it up to 1.5 amps of current, then the wire would burn away. So we just need to explain that. And this is actually, in the mark scheme, they've got 3 marks for this. So that's just an error in the printing. So you might not have said these second points. So in the mark scheme it says answer consistent with result from graph. Well, that's not very helpful, is it? So from the graph, 1 amp of current is 2.9 wires, but 2.9 wires is impossible, so would need 3 wires. That's our answers, 3 wires. And then, the fuse, or the steel wires in our case, would melt before there is too much current in the circuit. So we're saying what a fuse is. I think in this question they've missed out the marks, but they've also missed out why would you use this as a fuse. I think they should have written why would this be suitable for a fuse. And why would you do this? So this prevents damage to the circuit, the other circuit components, because the fuses are cheap, whereas other components like expensive bulbs are expensive.